my colleague Steve Schneider, who is from the biology department at Stanford, but that completely misstates his background. He's a physicist and an engineer and has all kinds of advanced degrees to prove that, and is one of the real movers, both at the global level in climate change and within Stanford in the new Stanford Institute for the Environment. And I, who don't have nearly so many degrees or qualifications, I'm a lawyer and an economist and tend to work on climate policy. And we're here to talk about what's going on in the climate area and certainly to respond to questions or things in which you guys have a particular interest. So I hope you feel really free to interrupt us, and we'll try and take the discussion where you'd like it to go. So thanks, Robin, and for having us here, and it's up to Steve now.
Okay. Thanks, Tom. And I'll just use this little thing here, and I'll do on that particular screen. I don't know where I got that from, and I hope that nobody's going to sue me for stealing their logo. But I figured, you know how you always write your company where you're giving a talk, and I said, I got an idea. It took a long time to figure out how to make that stay on the screen and not disappear. I wondered if you guys put something in it, but it worked. Anyhow, I'm going to try to talk about this question. Can we define, let alone fix, quote, dangerous? You'll see why there's a quote. Clearly, in 25 minutes, it's not going to be possible to give you more than a very fast overview of a lot of interrelated issues. And I think that's better than some technically detailed talk. Anybody has a technical question, ask it. And we'll do it afterward. Well, Tom is going to talk about Kyoto. That was just a cartoon that was in the subways when the Kyoto Protocol was negotiated back in 1997. You may remember that. It was amazing to watch an entire town linked around this. Of course, what I wanted to get to is that the Earth is looking kind of sad, and it's got the thermometer. And when I was showing this for another, I just did a medical book, on cancer, one of the students in med school were there, and they said, but that's not the accurate kind of thermometer. And I said, well, would have been an interesting challenge for the artist if we used the more accurate thermometer where to put it. And without losing a beat, the kid said, Texas, anyhow. Okay, so what do the thermometers of the world tell you? By the way, the least greenhouse gas emissions per capita in the United States is the state we're sitting in, and the highest is the aforementioned location of the thermometer. Okay, so here's what we call global warming. This is the sum of the thermometers of the world. They're widespread. I don't have time to go into why we have very large error bars early and not as large in the beginning, but you could probably figure it out. Much less coverage then, less reliable instruments, better now. This is a 5-year-old picture. You don't see that we've been up here and that there's a big debate with NASA saying we're now at the warmest year in the last several thousand, and the Brits saying, no, it's only number 2. But this made an entertaining media dichotomy, but in fact, they're a couple of hundredths of a degree apart, and nobody can tell to the statistical error, even to twice that. So all we know is that we're about 0.7 of a degree C, plus or minus a few tenths, warmer than we were a century ago. And that if you look back over thousands of years, you can find events like this one from 1920 on to 1940, but the overall combination, and particularly this rapid rise of almost ½ degree C in the last 3 centuries, last 3 decades, we can't find any precedent. And there's lots of what we call fingerprints to try to say how much of that is nature and how much of that is us. Global warming is not controversial unless you listen to those famous professors, Limbaugh and Crichton. What's controversial is the extent to which this is part of the natural system versus how much we did. Okay. Well, what contributes to it is greenhouse gases, carbon dioxide, and then there's, anybody know what that is? We were talking Africa, right? There's Kilimanjaro back there, and that's when I was very young and very thin. There was still snow up in Kilimanjaro. And the reason to point out termites is they're a natural source of methane. Methane is one of the greenhouse gases, a rather effective one. There's about 150% more of it than before the Industrial Revolution, about 30% more CO2, and we are pretty sure that we are responsible for that. Methane through a combination of land use, animal agriculture, and leaky coal mines and gas pipes. CO2, mostly burning of fossil fuels, some deforestation, cement making, and so forth. So we know all that, and nature is part of it, we're part of it. When we talk about climate change, we generally mean, and this is a definition, a legal definition, the anthropogenic, the augmentation to the natural system, because that has culpability, namely us, and then we look at the risks of those changes versus the costs of trying to fix it, and that tends to be the policy argument. But Tom will give you much more, and that it's much more subtle than that. Okay, back to Kilimanjaro. So here's the snows of Kilimanjaro rapidly disappearing. When I was there, somewhere around here. And it's amazing to think that in your own lifetime, about 30% of the ice disappeared. And it's not just there. This is Glacier National Park, a nice icon for ice. And the yellow and the red together were where the glaciers were in 1850. The yellow is where they were in 1993. They're disappearing fast. And our children, and certainly our grandchildren, will have no glaciers left in Glacier National Park. And most economists say, so what? They'll still go anyway. So then we get into the argument about what's important, how do we value it, and are things traded in markets the only measure of value? And we'll get to that one a little bit more later. Okay, let's get more local. So what we're looking at is from a century ago till now. The blue is the San Joaquin Basin rivers, and the red is the Sacramento Basin. Basically, this is a snowmelt map. Lifeblood of California is water, about 50% stored in various dams, controversial as some are. And the other half is stored naturally in snowpack. And if you get warmer, what a surprise, the snowpack melts earlier and is less there at the end of the season. So when you need it most in our Mediterranean climate toward the end of the summer is when you'll have less of it. Plus, if you're hotter, then you have higher evaporative demand for agriculture and cities, and you have more worries about forest fires. All of that has really focused Californians in an amazing way. It's been very bipartisan. I am actually pretty proud of the state that when Gray Davis signed the Pavley bill to control tailpipe emissions for greenhouse gases, currently in court with the automakers and the Bush administration on the same side, I was at that thing at the Presidio, and the Democratic governor was there. Now, just last year, a couple of my colleagues and I were sitting behind the governor, and that's because he not only accepted that bill, but he extended it to the largest greenhouse gas cutting announcement in the world. And we are the 5th largest economy, argue one or two, and the 10th largest emitter of greenhouse gases, so it had clout. So why can you get that kind of bipartisanship on this issue when you can't on others? And inside the Washington Beltway, it's hopeless. It's because we're already a couple of weeks earlier in the spring getting our maximum runoff. This isn't just theory. On the other hand, the theory says you get warmer, you melt snow. This is not surprising. And when people say, oh, well, there must be some statistics tricks, yeah, it's called ice melts at freezing. And there's the data of what's happened in the spring season. So this is warming, couple of degrees C in our area, larger than the global average, which is less than 1. Notice that it got a little bit cooler over there. And there are people say, aha, no global warming, I found an exception. Once I find an exception, I have disproved the rule. And you flip a coin 100 times. You do this experiment a bunch of times. You get 80 heads. Anybody think that coin is not loaded? Of course it's loaded. Well, when it comes up tails, that's the the 20% time. That proves the coin isn't loaded. That's the kind of nonsense you hear in the U.S. Senate right now. The kind of nonsense you read daily in the editorial pages of the Wall Street Journal and those famous climate professors, Limbaugh and Crichton. And it goes on all the time, and the media gives equal credence to these people, to 300 scientist studies that took 4 years. Tom and I are both involved in the Intergovernmental Panel on Climate Change, and we get pretty frustrated at the level of debate where all sides are given equal access, there's no quality control, and you only have 20 seconds to explain it. So what you do is you get equal status at the bargaining table for ridiculously non-credible positions, and the only way people can find out is if they go to your website and they read real stuff, and they have to put in sort of an affirmative action to do that. If we're going to get any policy to deal with these things, as Tom will talk about later, you have to have both governments, industry, and public buy-in, and it's hard to get public buy-in when they're bamboozled into complete confusion. Well, I won't talk about coral reef bleaching, but we know that a couple more degrees and it's going to be very, very difficult for these reefs to survive. You could value them economically by the fishing, you could value them by the tourists, or you could say, wait a minute, why does one species, us, have the right, when we're hell-bent on doubling our numbers as fast as possible and quintupling our economy as fast as possible, to knock out 20% of the rest of the species when we could have been just as rich 3 years later if we did it more sensibly? And in a way, that's where the debate comes along. And how you value these things is not science, it's values. Okay. Remember I said it's more controversial whether what we've observed, the warming is not controversial. I mean, there are still a few deniers around and even a few with PhDs, but they're a tiny minority and basically a joke in the scientific community. But how do you know how much we did? So this is some work that's done mostly here at Stanford. Terry Root, my wife, I have to confess the bias. I'm the last author in this. I'm the least important. And Dina Makmanowski and Mike Mastandrea did it. And what we were looking at is what we call joint attribution. It's been well known that if you look at climate models and surface thermometers, and you drive these models with natural forces like sunspot, effects on energy, and volcanoes, and then you drive them with anthropogenic forces, that means like greenhouse gases, aerosols, that you get higher correlation with the observed network of thermometers when you drive them with anthropogenic than with natural, and even higher when you do the sum. But then people have said, oh, the thermometers aren't any good, and the satellite says something else, which isn't true anymore. But all these arguments are out there. So we said, why don't we jump around the debate about the quality of thermometers, that they're not widespread, they're not all over the world, and let the plants and animals serve as a proxy thermometer, and that's what this is. So what we're looking at here is we're looking at spring events. So it's when flowers bloom, when birds come back, when eggs are laid. And there's a couple hundred that we got from long-term records. And there they go from 1970 on the left side. Is this laser working badly? Can I do this way? Yeah. It's from down here across. This is the index of phenology. Phenology means sequence. So 106 means 106 days after January 1. So 128 means that it's late in the spring. The 106 means it's early in the spring. And there's a negative trend. Exactly the same as the river runoff that you saw in California is replicated in birds and cherry blossoms all around the world. This is a global signal. We're a couple of weeks earlier in spring than we were. And this is consistent with warming. The question is, warming due to whom? So we went to probably the world's best climate model, which happens to be in the UK now. And we took a look at the index of phenology when you checked these plant and animal movements against an artificial data set produced by a climate model driven only by natural forces, sunspots, volcanoes. And what you see is essentially noise, nothing. A very, very weak negative correlation. What happens, and that's the lower left panel, when you drive it with anthropogenic forces? Well, you can see, there we are. It's quite negatively sloped, meaning earlier in the spring. Yeah?
Same as the first one?
No, they're different. Because the first one is observed, and it's against year, right? Because year is the surrogate for warming. Now, what we're going to do is we're going to take a look at the temperature which is produced in the model. So you could correlate temperature and year, and you could plot them if you wanted to that way. But this is a little more standard in the literature, so we just stayed with the typical model. But it could be translated. What you see is a downslope. And what that tells you is that the model driven by anthropogenic forces is getting much higher correlations with the plant and animal data for the early bloom than the natural. Not circumstantial, but it's got a very, very high, statistical significance. And then when you combine them, you do even better. Now, is this proof? No, but it's pretty compelling, and it's one of a bunch of things that we do. So when the scientific community says there's a discernible impact of humans on climate, it's a very, very credible statement. In any one system, and in any one system, you never know. Maybe we got the right answer for the wrong reason. So I'm not going to show this to you, but we disaggregated by birds, by trees, by continent. And of course, every time you do that, you get less of the variance explained, but you get the same basic pattern. It's pretty tough for this not to be real, and this is also consistent with what the thermometers told us 10 years ago. This is not a surprise. It's just it gets rid of the argument, oh, you don't have adequate thermometer coverage, because plants and animals don't know anything about urban heat islands. They don't know anything about thermometers moving out to airports. They just respond to what they get. So that was one of the reasons. So what I want to try to convince you is, yes, there's something going on, and yes, we're at least part of the story. Okay, so now let's get to this question, what was in my title, and I'm try to, what have I got, 10, 15? Yeah. Okay, good. So here's Munich Re, a reinsurance company, and they're not very happy about what they've been doing, which is paying out gigabucks, not talking megabucks anymore, especially for hurricane victims, but also for bushfires, the 30,000 people who died in the heat waves in Europe in 2003 when they had a 4 Sigma event, has certainly got the attention of that trillion-dollar industry. And they're sort of they're the boxing partner for the fossil fuel industry, which is generally in denial, and the insurance company is generally hysterical, and that's obvious why in both cases they do that. And so he said, we have to stop this dangerous experiment. So what does it mean? Well, let me show you the law of the land. This is the United Nations Framework Convention. Anybody remember the Rio Conference, 1992? Okay. Well, President Bush, as in senior, went there. He signed this, not initially, but he did. And then it was ratified by the U.S. Senate. So it is, in fact, the law of the land. And how many other countries, Tom? 180 something? I think it is the most signed international agreement in the world. 189. Okay. Don't read it all. Just the red is what we want to see. Stabilization of greenhouse gas concentrations in the atmosphere at a level would, here's the D word, prevent dangerous anthropogenic interference with the climate system. Great. What does that mean? Well, it means ecosystems should adapt naturally, food production should not be threatened, and economic development should be sustainable. Okay, fine. What does dangerous mean? Still not defined. So those of us in the IPCC, right, the Intergovernmental Panel on Climate Change, and I happen to be leading the chapter in Working Group 2, which is Vulnerability and Impacts chapter, is called Key Vulnerabilities and the Risks of Climate Change. In other words, what the governments want us to do is address Article 2. What is dangerous anthropogenic interference? So we scientists immediately kicked it back. Said, we can't tell you that. Dangerous is a value judgment. It's about acceptability. No, 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 you're the experts. So this football was getting kicked back and forth between government saying you do it, and we say you do it. And finally, the compromise that we reached, so far so good, is the role of science is to tell you what can happen and what are the odds. That's risk. The role of policymakers is to decide how much risk is acceptable and how do you weigh the loss of coral reefs versus the income gained by shipping companies when the Arctic sea ice melts. There is no calculus that can give you that as a right answer. That's value trade-offs across incommensurate dimensions of, or metrics of value. And there are a lot of methods out there. A lot of them are very mono-directed toward only one value system. And what we try to do is be as explicit as possible in the alternative views that people have on making those trade-offs. Okay, so who decides what is dangerous? Well, individuals, when they make decisions, villages, states, corporations, countries, and intergovernmental organizations, all defining it differently. If you're in a small island state, your belief is it's already dangerous. Coastal erosion, sea levels, and increased hurricane intensities have gone over the top for them. That is certainly not the view of people who are investing in oil sands in Canada. So, oh no, 5 degrees, we got 2 centuries, let's not worry about it, we need to develop, we need the oil. So you're going to hear all the time a classical debate. What's more moral, leaving the future richer, a legacy of wealth and infrastructure by not trying to shackle entrepreneurial activity now, or leaving the future having to deal with rising sea level, melting glaciers, knocked out biodiversity, increased hurricane intensities, and maybe flipped off Gulf Streams. So you're trading them off And a lot of the worst events are 100 years away, though you'd be building them into your behavior in the next few decades. But if you discount the world at anything over a percent, it has very little present value. Now the debate over economics comes down to what your discount rate is. Some economists will tell you that's prescribed by market behavior. Others will say, oh, no, no. When you're talking about planetary life support systems, markets have nothing to do with it. It's ethics. So this is all part of why, if you ever go to international meetings that Tom will describe, you hear such a cacophonous debate where the U.S. will sit and they'll do cost-benefit analysis of things traded in the markets and talk about rationalism, and other countries will say $1, one vote's not a rational paradigm. It's immoral for people who have money. And then there's no conversation other than finger pointing. Not a very good way to get international cooperation. So it's really key to get past that. Many ways to define it, and we'll talk a little bit about that, but it's ultimately, as I've told you, not a scientific choice. And worse, inherent uncertainty in every stage in what can happen, in what the consequences are, and in the costs of fixing it, and who pays to fix it. We used to start out with best guesses. It's going to warm up 2 degrees. That was our best guess. And people ran with that. And then we realized nobody buys insurance because of the best guess. The best guess is your house won't burn down and you won't get sick. So obviously, we worry about the range, the likelihood of nasty outliers, and we've been doing that. But now we've decided much more important to do PDFs. Now, and this audience is pretty sophisticated. So the next slide, which I actually stole from Mike Mastandrea, it works really well with unsophisticated audiences like Congress. That's the only PDF they've ever heard of. And of course, the one that we're talking about is the probability density function, the upside down, the upside down U, the bell curve. So what is that? This is how I think you have to be when you're honestly conveying what we know about global warming in the future. We're going to have 10% chance, this is a 2100, should have said temperature change above 2000 to the year 2100. Where did that spread come from? It came from 2 fans of uncertainty. One fan is human behavior. How many people in the world, what standards of living will we demand, and what energy systems will we use to get there? The other fan of uncertainty comes from the internal dynamics of the climate system, how clouds and other things going to interact and amplify or damp out what you predict. It gives you a very broad PDF. You got a 10% chance, that's 10% area under the curve, less than a degree, maybe doubling where we are. I think that means more Katrinas and Euro heat waves, but certainly not going to flip off the Gulf Stream and melt Greenland and West Antarctica. Then out here at the right-hand end, you've got a 10 or more percent. It hasn't even closed. I mean, the PDF's not even to 0. What that means is there's a small chance in the, at least in the single-digit percentages that we could have larger warming than the difference between an ice age and an interglacial cycle, which is 5 to 7, in a century, when it's thousands of years for those to play out. That is not a happy scenario. I don't know anyone who argues that isn't a dangerous scenario. So you're back to risk management. What risk do you want to take? Remember showing this, and a guy in the audience was an economist, and we're always debating, and I won't mention names, Tom, but whoever it might have been from Yale. And he said, wait a minute, Schneider, you mean to tell me you think that the really big events, the melting ice sheets, the larger reversibilities that virtually everybody agrees we don't want to happen, there's only a 10% chance of them? You want us to redirect industrial civilization for just 10%? And we were eating salmon that night, and I said, Joe, which was not his name, there's only 10% chance of salmonella in the salmon, so of course you're going to eat it. Right? When you fly home tomorrow, there's only a 0.1% chance the rivets are going to pop off the airplane, so of course you're going to hop on it. We routinely, what was the probability of WMD? We routinely make precautionary decisions in medicine, in business, and especially in the military at odds way below that. 10% is Russian roulette with a Luger, even though we're not talking about killing us. That's why I use salmonella. So it is completely irrational to argue that on the one hand, in business, health, and security, we have precautionary investments and actions for less than 1%, but in environmental science, we have to be 99% objectively sure. This is what's called dripping hypocrisy, or even worse, client pandering for people who write campaign checks, and it's up to us to point that out, and I, as you can tell, I'm not shy at that. So what we're talking about really is not truth, but risk management. It's about looking at ranges of PDFs, looking at the best that science can produce, and these PDFs were not drawn out of our left ear. We use a lot of data and a lot of information from multiple areas. Okay, well, give me 5? Okay. All right. So what we have to do is assess risk as a function of policy choices. What you do is you say, well, supposing we have a business as usual world with triple CO2. Then you go back and you feed those emissions into a carbon cycle model, which you then feed into a climate model, and it produces, you know, different strength hurricanes and different patterns of droughts and floods. And then you feed that into models of agriculture and look at the vulnerability of societies organized in various ways. And if you don't like the outcomes, you say, whoa, whoa, we get benefits by not being so warm. Then people take a look at, well, not being so warm means that you have to increase the price of conventional energy, like a carbon tax or some tailpipe regulation. How much does that cost? Who pays? And the cost-benefit argument becomes, how do you balance those two? Analytically, the way we do it is we do scenarios of future world organization, alternative technologies, and then we cost them through the sequence of models. So we're looking at risk, probability times consequence, and descriptive science, the objective part, is what can happen and what are the odds. But now anybody want to tell me what the objective data is on the temperature in 2050? 2100? Impossible. Frequentism, any of you out here are classically trained in statistics, you're not going to like me. Frequentism is useless for the future. What you have to do is use frequencies, observations of systems, various systems of the past, to construct models of reality as you best can do them. You validate them against past events or present data, and then you put those models together, models of atmosphere, models of ocean, models of ecosystem, models of population, models of technology, and together they give you projection capability, from which you can do Monte Carlo analysis, which I assume everybody here knows what that is, and that you can produce one of those nice bell curves, but it's a pseudo-frequency, because it's only as good as the assumptions that went into the construction of the models, which are based on current observations. The future is different, it's disturbed, and you cannot be sure that what you learned in the past is applicable, and therefore, in the end, the future is always subjective, whether frequentists like it or not. It doesn't mean it isn't expert. There's a lot of expertise involved in trying to pin down the relative credibility of those projections. That's how we do it. Now, to talk about this on the evening news, you get 20-second sound bites in front of Congress, 5 minutes. Not too easy doing that. I use gambling metaphors and insurance metaphors because it's very difficult to explain truthfully that we don't have answers, nor will we have direct answers in decades. What we have is ranges, probabilities, outcomes, distributions of winners and losers, and we're back into risk management. So the normative judgments, the value judgments, what is safe, what is dangerous, what is fair, and who should pay. That's the political argument, which Tom will tell you about. So you could say, well, let's just internalize the externality. This is back from the Bush 1 war, and this was a Scientific American cartoon, right? The gas was $1,000 a gallon. We have a little while for that yet. And of course, the joke was that, wait a minute, we're underpricing because we spent all that money defending the lines of oil supply. That's what you call internalizing externalities. It's an externality to the energy companies. What happens to the asthmatic problems from people who have to breathe air pollution from improperly controlled exhausts, or the rising sea level, or intensified hurricanes? So all of those have real costs, and if they're not part of the cost of doing business, then what you're calling a free market is in fact a rigged market, and it's rigged toward the status quo. So everybody here has a garbage can picked up once a week, right? Mine at Stanford cost me $5, actually cost $6 because I'm lazy and I have them pick it up on the curb. If I put a second, I mean up on the driveway, not on the curb. If I put a second one out, it's $2. Why don't they charge $5 again? Well, because the truck is there and the guys are there, and it's economy of scale. Why isn't it free? Because there's labor, truck, landfill. Why is my tailpipe, your smokestack free? What is the free market logic, which I hear over and over and over and over and over from the U.S. Senate, that it's an interference, or from the energy industry, or from that somehow this interference in free market? In fact, it's restoring a free market to charge the full freight. It's just doing things differently, and it gores oxes that are very powerful. So that's, again, where it's so important to do this right. Well, we have certain policies of volunteerism, and I love this cartoon because can you imagine the highway carnage rates if speed limits and stop signs and traffic lights were voluntary? Am I done? I'm done. I won't tell you about New Orleans now. Ask me about it later. But the bottom line about New Orleans is, despite the administration and others saying it was natural event, yes, we don't make hurricanes, but we can soup them up. And in fact, there's very strong evidence that there's a big increase in the number of Category 4 and 5s. And it's definitely highly correlated in both oceans to ocean surface warming. And that's a side effect we're already seeing. How much we want to spend getting off the fossil fuel carbon addiction we're on to be able to slow that down, that's the political debate. Okay, thanks.
After Tom speaks, we'll have a question.
Sure, as long as people want. You're going to need a little laser, or this didn't work too well, did it?
Because we might have another one. Actually, you know what, Tom? There's power down here.
Yes, sir.
Press it one more time.
I don't know if I want to watch this.
There we go. Oh, there we go.
I'm reaching words wrong.
What did I do?
Yeah, and then.
Yeah. Here we go. Forget where I am here. Okay, look, it's going to have to be really quick, and Steve has already done a lot of really good work, and oh, thanks. Right, I tend to wander, so now I'll stay here. I'm going to talk about policy issues, and I'm going to be brutal and provocative, and basically, Steve was, gave you the outline that there have been two big steps in trying to deal with building a global regime to handle the problems that I hope Steve has persuaded you are very real problems. The first steps were taken in Rio in 1992 at the Earth Summit. The second steps were taken in December 1997 at Kyoto with the writing of the Kyoto Protocol. The negotiations have been continuous since that time. There have been lots of battles. Remember, the U.S. left in March 2001 after the negotiations had essentially broken down in meetings at The Hague in December, the end of November, beginning December 2000, when the election was just hanging in the balance before the Supreme Court, and no one quite knew who was going to succeed to the Clinton administration. But the latest events took place in Montreal. A little over a month ago. Robin and Sergey were there for part of this circus. And I'm going to try and both bring you up to where things are and give you just a little bit of an explanation of why I think we have run into what effectively, I'm sorry to say, may be a dead end with respect to the way we have framed and tried to remedy the problem so far. I hope I'm wrong, because I don't terribly like the idea of starting over, but much of what I'm working on and what a book that some of this presentation is drawn from will be about are about alternative approaches. If it is true that we have run into kind of a political cul-de-sac, a dead end on the way that we've been approaching things so far. So let me just make a few points here, and the book is going to be structured, or at least the first part of it, about a series of myths. I'm just going to talk about a couple of them right now. Climate change is not a problem. Steve, I hope, has simply destroyed that. These are just some issues that people like Crichton and Limbaugh and others tend to bring up. In fact, some scientists do. I'm not going to spend any time on that because Steve can do a better job and it's not worth it. I do want to talk about a couple things. Sometimes people say, you hear all this debate about peak oil or that fossil fuels are running out, and the problem's going to solve itself because we're going to be out of the major sources of fuels that are the principal sources of greenhouse gases. If we put our money there, we're going to lose our bets, because what we're seeing around the world right now is that reserves of fossil fuels, even in the oil and gas sector, let alone the coal sector, are a function of price. And when price gets up in the levels where we are right now, in the $60 to $70 range, you get a whole series of reserves coming online. Some of them I've listed here, heavy oils, whether they're in Venezuela in the Orinoco Basin or up in Canada and Alberta in the tar sands, or enhanced oil recovery, deep water and cold climate drilling. There are a whole series of reserves that are out there that don't make, or let me put it this way, that delay any argument that we are running out of fossil fuels to a point at which we will have already cooked ourselves and done the damage that climate is threatening us with. So I just don't want to stay there. There's lots more data we could do. Interesting pictures that you may have seen. We could obviously do a much better job with Google Earth than these pictures are so far. But many of the problems, if you look at where the lights are on, which is basically the white, relative to where the major fossil fuel, and this means oil and gas rather than coal, reserves are, you'll see the problems are essentially infrastructure or transportation problems. It is moving the gas from where it is found to the places where the energy is demanded. But those problems, while they're extremely important, are not the same as we're going to run out and we have to do we have to take certain measures in order to forestall that. There are interesting issues that are worth talking about in the question of the intersection between energy security and the way we get our power. Because it may be that prices, when you do add in security costs, are escalating to a point at which alternative fuels will actually be commercially more successful than they've been in the past. But if we do have a less carbon-intensive future, it's not because the fuels are not there for the significant period that would produce that result. Okay, I'm not going to say too much about this engineer's myth here. It's something that we're spending a lot of time working on, but I just want to make a couple of points. There is a sense often among people that if you come up with a technological solution, it's going to spring forth and multiply. In other words, conceptually, if you figure something out, that it's it really does provide a potential solution to a problem like climate change. The problem, of course, is really the speed, the scale, and the price paths of various technical possibilities. And as you can see up here, these are just highlights from various studies of past experience. The problems of getting from a very good idea that is in the mind of some engineer to something that is commercially sustainable over time is a much more complex path, and it often involves what we could call fight back by existing technologies. And this is particularly true in the fossil fuel sectors because there's a huge amount of room for prices to come down as they become threatened by alternative sources. So the big question, and I'm going to come to this at the end, is trying to figure out what we can do about trying to speed up, increase the scale, and lower the price paths of technologies, which often means focusing on a lot of stuff other than the pure science. It means focusing often on institutions and problems that get in the way of a technology coming forward from somebody's good idea to a commercial scale that diffuses throughout the world at a pace that is much more suited to solving the problems. I'm going to skip by. We've got a lot of data on learning curves and all the rest of that stuff that'll appear in the book. And the only thing I will say is that historically, as this will show you, there is a very slow evolution in primary energy systems. In other words, there has been a cycle often of about 50 years in which you see substantial shift occurring in which one dominant fuel source changes its proportion of the total portfolio of fuels, and that's largely because most fuels run through complicated infrastructures. And once those infrastructures are in place, they're going to be there for some time. And the issues associated with this are extreme at the present time because I'll just give you an example. I spend a lot of my time in China and India. And in China right now, they are building in the past year and a half at a rate of about 70 gigawatts a year of power. Okay, it's England's power source being added every year and somewhat more. If that's coal, given what we can do at the present time with engineering, we used to say the lifetime of a coal plant was 35 years. That's ridiculous now. A coal plant lasts practically forever with what engineers are able to do to it. Nuclear plants, we used to say, had a 40-year lifetime. Not anymore. A nuclear plant is at least 60 and well beyond because the engineering is improving. So what we do now matters tremendously in terms of the climate footprint that we put down in the future. Okay, now here's where I'd like to focus a bit more of my argument to you. And it's pretty simple. I would certainly stress that the problems that we're experiencing in the Kyoto regime and the policy side of dealing with climate are certainly not problems caused by scientific disagreement. Steve has made that point, and I think it's absolutely true. The scientific evidence, the consensus about what is happening is overwhelming. And I want to suggest to you that another problem that people often throw up as the reason why we're having such difficulty in policy is because we really haven't designed the regime very well. We haven't had smart enough people who know the economics in there, and I want to argue to you exactly the opposite. I want to argue that in the years that I've been working on this, which has been since 1992, I'm not quite as long as Steve, but I've been at it for some time now, the last thing that is the source of the problem is weak economics, in the sense of people who are trained economists at a very high level applying themselves to solving this problem. Indeed, I would argue that when we look at the structure of the Rio Treaty, the United Nations Framework on Climate Change, and on the Kyoto Protocol that was formed under that framework treaty, you see a structure that anyone teaching Economics 101 or environmental economics at Stanford or any other good place would say, gee, they did a pretty good job of figuring out how you're supposed to deal with a global problem like that. And let me just illustrate what I mean. The first thing, we know that climate is a global collective good in the sense that it doesn't matter where in the world you put climate, you put greenhouse gases into the system or where you pull them out, the effect on the overall climate system is basically the same. That doesn't mean the impact is the same. It's different in California than it is in Africa. But what it does mean is the emissions and the sequestration, the addition or removal of emissions happen anywhere. So everybody ought to be involved. Global good, you should have a global regime, and that's what we've done. That's why we've got 189 members in the climate change negotiations at the present time, because it's theoretically correct that everybody should be part of this system. Secondly, we have overwhelmingly focused on cost-benefit analysis to set the level of stable concentrations. That is, what is the goal? Well, if you've spent time within the IPCC, the UN body of experts that deals with this, what you have are big attempts to figure out what the costs of reducing emissions are, and much less successful attempts to figure out what the damages avoided would be. But the goal of this thing is to figure out at the margin how far you should limit climate concentrations, because it's a standard economist viewpoint. You figure out where it is that the benefit of the last unit of reduction equals the avoided damages of avoiding. Of having less climate risk. So the theory is absolutely an economist theory, and it goes further by saying, how do we deal with this problem? Well, what they've done is they've come up with a property rights system. That's the whole structure of these treaties. And what do I mean by a property rights system? Once you've figured out what is the allowable amount of emissions by doing, in theory, cost-benefit analysis, you set that as a cap. You say this is how much emission is allowed in the world in any given year or any given 5-year period. And then you distribute rights to emit that much carbon or carbon equivalent across the whole world. And in so doing, you've got to figure out, of course, how much does India get, how much does the US get, how much does China get if everybody played in this inclusive game. They don't at the present time. But you have to figure out some way of allocating these property rights, and then what you want to do is allow people to trade them. Okay, and because what you have in that way is you will end up, as any halfway decent economist will show you, you'll end up with the lowest cost emitters being the ones who do the reductions. Because as long as you can reduce for less than the traded price of these permits, what you're going to do is you're going to take those reductions, pay the cost, sell your permit, get your money back, and make a profit. And if your costs to reduce are higher than the average or the traded price in the world, you're going to buy more permits because it's cheaper for you to buy the permit than it is to reduce your emissions. So it's a situation that is designed to produce a single world price, the traded price that will operate globally. And at a global level, if everybody played, you will get the lowest cost reduction, lowest cost for any given level of reduction. The other things that I'd simply stress there are the models is one that's kind of based on the model of a national state. If you break the law, so you've been given X number of property rights, X number of permits that you can emit, so many tons. If you break the law, somebody's supposed to come down on you. Same as if you stole something or if you violated some regulation here. Of course, it's a big question at the international level who that is. Who's coming down on you? And what are the types of sanctions? Because traditionally international relations don't have somebody like the EPA or some other agency that is available to do this. Finally, there was one necessary trick that got thrown into the works from the very beginning, which was that although the whole idea here is to do this on a global basis, the developing countries, from the very beginning, before this started, indicated that they wouldn't play. Okay, why? Because they were not going to see constraints in the amount of emissions that they were permitted to have limit their development. So we imagined, somewhere in the back of our academic minds, that there would be a process that we called graduation, which we got from the World Trade Organization, that says developing countries should have special trade status in the various tariff structures that we have. But when they get rich, at some level, they graduate, and then they lose their special treatment. And so the same idea was in the minds of planners here, that there would be some sort of a process in play that would suggest when countries reached a certain level of income or some other standard, what we left undefined, they would enter into the system so that eventually, with growth, it would indeed become global. Okay. Now, how are we doing just on time? So, okay, that's fine. That's plenty. All right, the history of the negotiations between basically 1992 and the present time has been in some important part a playing out of difficulties in implementing this economic model. Okay? It has not been dealing with what I would call the hard problem, which is the issue of when developing countries, no matter how large they are as emitters, and China will surpass the United States as an emitter, as the principal emitter in the world, sometime between 2015 and 2025. It's not clear. It depends on Chinese growth rates and other difficult things to estimate. But we've never really, at any point in the negotiations, taken on the hard question of the relationship between North and South, the developed and the developing countries, except in an extremely indirect way I'll come to in a minute. The fighting has gone on only between the rich countries, because it's only the rich countries who ever assumed obligations under the Kyoto Protocol. Okay, they were the only ones who ever, what's called Annex 1 countries, and the lingo of diplomats and lawyers who do this stuff. They've been unable to agree with one another to the point that the United States and Australia actually walked out, and the negotiations have been very colored by the inability of countries to agree on a whole series of things. These are some of the things that I think are difficulties that we have consistently experienced. I'm going to come back and talk about one of them in just a second, the trading instruments which we have created require financial regulators of a type that don't exist in the system. It's exactly as if you had a securities market in this country, but you didn't have an SEC. You didn't have anyone to worry about the quality of what was being traded. We had that in this country for a while. We used to have watered stock and all kinds of frauds and things that went on. And part of the problem is we're experiencing some of that at the present time in the implementation of the Kyoto Protocol, because we lack the institutions that are there. But I would just want to focus on one thing down here at the moment. You know, we talk about having a single price signal for disparate goals in climate change. Right now, if we look at European markets where you see trading going on, because Europe did enter the Kyoto Protocol, you'll see that the trading, which is very thin and very spotty, in the permits that have been allocated to the different members of the European Union, is trading somewhere between 17 and 20 euros per ton of carbon. Okay, it's a price that I think is unstable for reasons I'll go into in just a second. But it's a price that if we apply this, and we've done some analysis, to a number of US utilities, okay, if that were the traded price, they're not going to change their fuel composition one bit. In other words, that price is not nearly high enough to cause them to change their the ways that they are currently producing. Now, that produces a real problem for us, because I think a lot of the theory that has gone into this is, well, we'll set a low price signal at the beginning. That's what Kyoto is doing. And then as things get more difficult and we see that the science is firmer in the minds of the public, that we'll be able to ratchet up the signal. In other words, instead of being $22, we'll raise it up toward $100, where it has been more or less $90 to $100, simply because of the gas price rises we've all been facing. And we can make our own judgments about what that has done to our economy. But the idea that we can solve the various problems, and I'm going to come back to this in a second, that are implicit in dealing with climate across time through a single price signal are very difficult. I believe strongly that a low price signal, such as the one we are experiencing in part of the world, is very adequate and indeed necessary for dealing with a part of the problem. I don't think it is at all necessary for it is at all adequate for dealing with other parts of the problem. And I think the difficulty is in part that industry everywhere, and I think this is as true of Europe and China as it is of the United States, is extremely resistant to opening up the possibility of a continually rising price signal. Okay? In other words, I think that they would be quite comfortable with a price signal at the level we're experiencing it right now. I think what they're afraid of, in good part, is that it's the camel getting his nose under the tent. And once they open this up, the price signal is going to continue to go up. And in fact, that's what the economic analysis suggests is going to happen. So there is this political paralysis that is occurring, not so much on the level of the price signal at the present time, but on the structure of a regime that will open the price signal to areas, to levels of which they are extremely afraid. Another problem that I want to point out, and then I'm going to jump over and talk about what I think are some of the solutions, because we have a limited amount of time here. I think it's a mistake to focus as strongly as we have on kind of a pure economic analysis. I think what we are doing is missing all manner of difficulties that exist in the reality of how people respond and who responds to climate change problems. So, for example, energy security is now an extremely important priority among politicians all over the world. In some cases, that's good from a climate perspective. I mean, if people build nuclear, whatever else we think of nuclear, because they can keep the nuclear on their own country, that at least has a lower carbon input. It has other problems, proliferation, and I needn't go into those with you here, but it's beneficial. Obviously, renewables can have a strong dimension of energy security to them because they allow you to actually keep your energy industry at home. But in China, energy security means one thing, and that's coal. And in India, it's the same story. When you look at the distribution of coal, energy security is not climate friendly in any fashion, and yet energy security dominates in national politics everywhere I know. Various types of environmental considerations. Climate change priorities are extremely low in the countries where I work, and as that includes the United States, relative to economic development and local pollution. Lots of others that are there, but I just want to point out one thing that's here. People keep hoping that we can create a policy regime that is going to induce technology change or create various types of climate controls that are effective in changing people's lifestyles. Everything we know historically tells us that effective policy usually follows technology or price shocks. It rarely leads them. And I'd simply point to telecom and information technology where you guys are. What happened was a technology shock led institutional change. It was the technology shock that destroyed the old regulatory and monopoly structures of the telephone industries and the like, rather than the other way around. So what I want to argue, and I'll spend a lot of time on in this book, is trying to understand other factors of economic factors that affect decisions. And very importantly, among those are issues in organizational theory. I mean, basically, it's sad to say in some ways because we all love to think of our organizations as being innovators and the like, but basically organizations do what they do. Okay, most of the time when change occurs, it's not because of organizations adapting to new circumstances, it's because new organizations are being selected by the changing picture of what is needed. And, you know, here we are, right, all around us. And the idea that we can take existing organizations like energy ministries that have been around for a long time and control enormous political power and tell them, now you guys are going to adapt. You're not just going to be an energy development ministry, you're going to be an environmental ministry as well, and you're going to do it. Extremely difficult to get people to shift their organizational cultures. So these are the kinds of things I want to focus on. Okay, what can we do? I'm going to skip by a whole lot of junk here. I do want to make one point in passing, which I think is important to the rest of my argument. This is where the world's emissions come from. There are a very small number of countries who dominate the world's climate emissions. Okay? And instead of having 190 people around the table, you had the right 6 or 7. You could deal with the greatest part of this problem. And that's going to be essential for thinking about what kind of a regime we're actually interested in creating, because what's going to happen is emissions down here are going to grow most rapidly, and indeed there's going to be more concentration of emissions in the future than there has been up to this time. Here's the punchline and where my work is going, and where I think, if I'm right, that various types of difficulties are causing Kyoto to not be able to solve those various problems that it's been confronting so far, the most important of which is the relationship between developed and developing countries, but lots of others to which I very briefly alluded. Here's what I think we have to do in thinking about a different way of approaching it. Climate is a derivative problem of three economic sectors overwhelmingly. And the key thing about climate, as opposed to, say, the Montreal Protocol for ozone-depleting substances, is these sectors are at the very heart of what people mean by growth and development. Okay, these are third rail sectors, in the sense it's the energy we use, it's the transport we have, and very often it's the land use, the use of land and spatial topographies that we make. Okay, the government actors from these sectors make decisions on the development paths their economies will follow. Who are those guys who make those calls? They are the line ministries, the energy ministries, the transport ministries, and they are the finance ministries who control the budgets for investment that these guys need. Okay? The political priorities of these actors are nowhere, especially in the developing countries, focused on climate. And when they look at the world of environmental constraints, which they may be hearing from their environment ministers, who see this as an important problem and one that, frankly, will help their own leverage grow internally, they hear nothing but constraints. And when they hear constraints, they really pull back from it. And if we were in Montreal, or when we were in Montreal a month and a half ago, if you went around that room and saw who was negotiating, none of the people who were there were the people from the ministries who are making the calls on national development priorities. Okay, they are overwhelmingly environment ministers or foreign ministers, none of whom, honestly, have any power whatsoever to affect the energy trajectories or the transport trajectories in their own countries. Second point I want to make, beyond we've got the wrong people at the table involved in these issues. The second point is there are really three problems. We have a current problem that we can see all around us. In an intermediate need for a low-level price signal. There are lots of opportunities. Steve is one of the world's real experts on them, for energy efficiency that may even save money, or at a very, very low price signal will cause people to change their behavior. And these things are legion. We need incentives. And it can be quite a low-level signal. $10 a ton of CO2 is probably sufficient for most of it. To adopt options to mitigate carbon where the incremental costs are low. We would get big savings from that, and they're available in the short run, and some companies are already realizing them, and we need more of them. The second problem we've got a midterm need to diffuse more rapidly than business as usual existing commercial technologies that are relatively less climate damaging. Now, most of those, or many of those opportunities, because we're talking about the diffusion of technologies that are known in Europe and the US and Japan, but are not penetrating China or India at nearly the rate they could. So these are issues in the countries that are not taking on climate obligations, even a low-level climate signal. We need another structure than Kyoto to create what I'll simply call deals with them, to get them to alter their development path. And I think if we had more time, I could go into a number of such major deals to which I think interests in those countries who are mainly concerned about development as their highest priority would say, yeah, that's something we want for our own country. And there's lots of, the question of exactly how you structure those deals is going to be particular, but I think we need to spend a lot more time on it. Less regimes, less general rules, more business deals. Business now including some of the money that we may be spending on Kyoto and stuff that can be directed into the public dimension of those cooperative deals between private industry and public agencies at an international level. The long-term need is to develop energy, transport, and land use technologies that are currently across the commercial the horizon, and I think we need a huge amount of work in understanding what is the portfolio of technologies that's out there, and what are the problems in getting from good ideas to rapid diffusion at scale of commercially sustainable technologies. In order to do this, what I'm just going to close with is each separate climate problem is best approached through a separate institutional pillar tailored to the specific problem. In other words, I think we want to move away from having a general regime, as we've tried to so far under good economic design, and think about multiple pillars. And I use that strange word to American ears because the Europeans have built the European Union around different pillars, meaning different institutional arrangements. One thing for trade, another thing for foreign and security policy, another thing for justice and immigration, a fourth for monetary union. And each one is a separate institution with different players who are really appropriate to it. You don't need 190 problems if you're going to work on carbon capture and sequestration, because there only are 3 or 4 countries who matter in that. And those are the ones who I think you're going to have a much more likely chance of reaching an agreement between than we are so far. The Kyoto Protocol, as it now stands, strikes me as a well-tailored arrangement for a low-level price signal. And I think if people understood the Kyoto Protocol as basically that, even the United States, with any kind of rational administration, and I'll leave it to you guys to decide whether we have crossed below that threshold, but a $10 to $15 carbon price signal is perfectly saleable in this country. There's a new bill by Senator Bingaman out that basically works at that level. And I think we will come to that as long as industry comes to understand that it is not the first step in a ratcheted up arrangement, that we are going to come up with other instruments to deal with the larger and more salient elements of climate change that need a much deeper set of institutional incentives than we have. And I'm not going to deal with the rest of this because we're out of time, but there are like 150 more of these things, and another time. Thank you.
Now's a good time for questions, and I think we need to speak very loudly so the video can hear you ask the question.
Actually, the speaker should just repeat the question so it's captured.
Oh, got it.
Good idea. Questions? Trading? Anything you guys want to talk about? Yeah, go ahead.
Yeah, given that the EU is on board with the Kyoto Agreement and Montreal, and the other major polluters, US, India, China, are not, right? Yeah. Isn't there a sort of a case to be made in the World Trade Organization, for example, that says the member countries, the EU and the private organizations say our cost of production is higher because we have adhered by these sort of carbon trading policies?
Yeah. No, a very interesting question. The question is, look, the EU is on board here. The US and the developing countries are not. So isn't there a way of saying through the apparatus of the World Trade Organization that there are unfair competitive conditions going on, and presumably, just to finish your thought, that we have a right to impose either border controls or some sort of trade barriers against goods produced in the countries where you do not have carbon constraints. There are 2 to 3 problems with that. One, you know, the WTO can't work against China and the United States. In India, they're too big in terms of straight power. There are all kinds of legal problems. To be very brief about it, and I'll be glad to talk about it separately, there are WTO decisions after 2002, the so-called shrimp turtle decisions, that indicate that countries may be able to impose trade barriers against activities outside their own borders, which is what this would be. But those barriers, and here I'm going to sound like, you know, usual crummy lawyer, get extremely tricky if the situation is such that the polluting element is not becomes mixed into the good which is traded. To say that in, you know, human terms, it means if you're using polluting energy and it is a productive factor within a particular good which is now going to cross lines, that cannot be under WTO law excluded. It's only when the factor is in some way identifiable or related to other types of production conditions. Shrimp turtle is limited. So there's both political and legal problems why this would be the case, although the Montreal Protocol did include trade sanctions in it, but they've never been used. And the success we've had under the Montreal Protocol is not a fact of a hard law model, because hard law in the WTO is very hard to apply against countries like the U.S. I just will say one thing that builds on. I see this thing is back here. When you actually consider the number of countries in the world who have assumed what I would call a positive price, that is, they actually have a charge that is raising their industrial cost or the residential cost for people, it's an incredibly small number, because most of the signatories of the Kyoto Protocol are developing countries who have no obligations. 16 of the signatories are countries that were part of the former Soviet Union or Eastern Europe, who are sellers in the system, meaning they received more permits than the actual amount of pollution they produce after the breakdown in their economies that occurred. They're allowed to emit as much as they did in 1990, but their emissions are actually lower. So those guys are not facing a positive price. They're trying to make money by selling these things to other people. The ones who have taken on costs are basically Canada and Japan. In the negotiations after the U.S. quit, they both got major concessions that cut their costs somewhat, that the Europeans gave them. But the Canadians, for example, are way, way out of line with their Kyoto targets. They're not coming anywhere close. And with the elections last week, I mean, first Alberta had said to the Canadian government that they had no right to sign this treaty anyway. It was a provincial matter and they weren't going to pay any attention to it. But even getting beyond that, the Tories, the Conservatives who won, are going to make no effort to enforce. And my final point is twofold. One, within Europe itself, many of the countries of the Union do not have obligations to reduce emissions. The reductions in the Union are overwhelmingly done by the Northern European countries, Germany, Holland, and some others. And given the fact that they are facing relatively high prices, they're making use of a complicated trading mechanism called the Clean Development Mechanism to essentially get tradable permits at prices that are down in the $4 to $5 range in order to bring down their costs. The market is slow at the moment because the approval process for these things is not as fast as people would have hoped. But the reason why the European trading market is so thin is European actors are waiting to see how large is the supply of CDM permits that are coming in right now at about a quarter the price. So it could be that compliance in Europe ends up being not the $20 that I referred to earlier, but more like $4 to $5. And that doesn't provide much of a price signal for much of anything. I'll be glad to go into that in much more detail, and that's one of the areas where I spent years trying to design that mechanism and almost completely screwed up because I didn't understand how it was going to be gamed by people who could work their way around the rules.
Just one brief point on that. I won't talk about the leakage problem that he talked about. That's when if you have low energy prices and a non-complier and therefore their products have embedded energy in them that's higher or cheaper. The other problem is you hear so much nonsense about how the costs of compliance are going to be bankrupting countries. In fact, George W. Bush said at Glen Eagles that Kyoto would have bankrupted America. I think that was close to his phrase. And almost all the economic studies that looked at a relatively bad Kyoto without many trades were particularly giving you carbon prices in the order of $100 a ton to meet the obligations. The $1.50 a gallon gas price increase that we had would have taken the equivalent of over $200 a ton. The economy is doing fine, and in fact, we've already proved that it was nonsense. People have run economic models with the full carbon tax. I did it with Christian Azar, and what we showed was that the costs of even pessimistic substitution of cheap energy for more expensive energy would probably run in the trillions of dollars present value if you did it without what we call correcting market failures, is still a small fraction of the growth rate of the GDP, and even $6 trillion cost 100 years from now in lost GDP on the $300 trillion GDP you would have means that in 2 years later, the doubled population of the world is 500% richer in 2102 than in 2100. So this nonsense you hear about the costs are prohibitive and are going to destroy development, it's just nonsense. It is not nonsense for the coal industry, for large autos, and special interests. So part of the governance structures, and I agree, by the way, with the pillars, will be trying to find ways that you can get actors willing to do it when they know that they're the frontline losers of this by side payments, or if you prefer, bribes, legal bribes. What you need to do is try to find ways to be fair as well as efficient, and bludgeon rules don't do that very well. There'll have to be some pick and choose, and then people say, you just favored them. But if they're the ones paying the highest price, well, maybe we should favor them at least the first 20 years to get started. So there are creative ways to get around this without dealing with WTO and other things. At the moment, there's no creativity because there's no desire, at least in this country, at the top and the federal level, to even fashion such solutions. The good news is the states are, cities are, some members of Congress, and sooner or later, this heterogeneous patchwork quilt of different rules in different states, which in my opinion is not a rational way to help companies meet their obligations, would be better met through federal rules, will probably lead to a sea change where there will be federal rules because companies will demand it, not we on the environmental side. We don't have any clout. Carl.
Go ahead. We've heard him before. Has anybody done any analysis on what price equivalent per barrel of oil it would take to enforce what the Kyoto Protocol would enforce? In other words, would $200 a barrel be enough to enforce the energy regime?
Way below. Kyoto Protocol is way below the current increase that we've seen. We've seen the oil climb from $20 a barrel to $60 a barrel. That's way more than the cost of enforcing the Kyoto Protocol at equivalence. You just have to run it across all sectors rather than on the transportation sector alone. But we do see, I mean, in places in China where, as I said earlier, I do a huge amount of my work. If we looked in 2003, 2004, we would have seen fuel oil being burned for electricity in large numbers of small operations across Guangzhou or any of the eastern provinces. And if we go there now, you'll see almost no fuel oil being burned, except in there's stuff in the bottom. They burn asphalt in effect, or tires, because they're so short on power. But the fuel has been the oil has been shifted overwhelmingly into the transport sector, and that's one of the reasons why the coal increase is so fast. They've basically emptied out their fuel oil capacity.
And even in the good old US of A, there are places in the Northeast that are burning unbelievable oil for direct heat of houses through single-pane windows and leaky infrastructure. Those are the cheap things to fix. And New England, for example, and New York are actually taking action to do that.
So Mr. Chavez is not helping us by giving free fuel oil to people in the Northeast.
I just wanted to ask, I always feel like if economists understood consumer behavior, you'd see nothing but a parking lot full of Hyundais out there, because it clearly has the best cost-benefit ratio of any car you can buy. Given that consumers make decisions based on fashion, style, attack aversion, and all kinds of factors other than cost, who's doing the best work to adjust our culture so that conspicuous consumption means saving the climate rather than trying to kill as many dinosaurs as possible? And is survival going to become a value that consumers are interested in as one of the attributes of their product?
To me, it's as if I knew something about this. Good. I hope you do. I get a lot of my research money. I probably should have confessed this in the beginning from British Petroleum, which fancies itself as the most green of the energy companies. It's always questionable exactly what that means. They're trying like crazy to market a whole series of of products that are niche products that are designed to appeal to various green consumers, and they're trying to. I mean, look at the Financial Times or anyone else. You walk into Heathrow Airport, what do you get? Nothing but BP. We're the alternative energy company. I mean, they're really on a massive campaign, without divulging any confidentiality at this point. Marketing people can't find a trace of a signal. Okay, so far. So I'll let Steve. I think it's a major issue you're on.
You're talking about lifestyle, what we really care about. And I spent a fair amount of time advising groups in Hollywood. And there's a very well-known actor who does a lot on global warming stuff. And my wife Terry and I read his scripts and make sure, because he wants to say the right thing. But when I was advising one of the groups about 10 years ago, there were a number of actors, I won't mention names. What they wanted to do is they wanted to do TV spots where they were basically playing scientists and teaching people about science. And I was strongly against it. I said, wrong role. I want Tom Cruise sitting on the hood of his hybrid while some big clunky fool is trying to impress the ladies with his Hummer. And what you want to do is you want to send value statements. Don't play scientists. You're not credible at it. A lot of them didn't want to do that. And so you can use that group in value-directed ads, but somebody's going to have to fund it and get there. And make certain that they're not writing the scripts. They're going to have to get some good advisory in. The other thing is, I'll just go back to a simple trade-off which takes us back to this disjuncture between legacy of wealth and infrastructure versus cultural quality of life and other changes. The Arctic sea ice is melting fast. We know that we're responsible for most of it, never mind the liars and spin doctors who deny this. There's uncertainty in every aspect of everything, but it's very likely that it'll get worse. So how do you weigh the benefits to the shipping industry, which have shorter pathways across? The Russian admirals are thrilled. They've been wanting this, warm water ports forever. And you can even calculate how much CO2 you can save from the shorter routes, and it comes out, I don't run the numbers, but it's tens of millions, more than that, of dollars saved. So if you're doing straight cost-benefit analysis in the $1, one vote aggregation rule that they do in the Office of Management and Budget, what you're going to end up saying is big benefit from Arctic sea ice. Now you're going to wipe out the polar bear. That ecosystem is gone. The Arctic fox comes along with it. Well, what do they do for our economy? What about the Inuit cultures or the other indigenous people whose cultures are built around the touch of sea ice to the shore? Now, they're not dying from this. In fact, I've heard it said, well, once we put ANWR up there, they're going to make a fortune running the oil rigs. But that's not the culture that's established. So what you have to do is find equivalences in metrics other than things traded in markets that people truly value. That's where what we were doing earlier when we were talking, maybe Google Earth can help. You need to have metaphors that catch people where they have true value in their guts and get them away from the notion that the only metric of importance is how much money you have at the end of the year. So we're really arguing about a battle of value. It's not a battle of economics. I would argue climate change is below the growth rate in the GDP on both the damages side and on the cost side of fixing it. And we've got a lot of studies on that. If I pick really bad damages, maybe we'll get a couple of % of GDP. It's pretty tough. Katrina, current bill, $200 billion. It'll probably double by the time we, have ancillary expenses there. What's the size of the U.S. economy? 10 trillion? What's 2% of that, our growth rate? 200 billion. So it's 1 year knocked off us. In 5 years from now, yeah, it'll be a little bump. It was like the population growth rate curves after the 1918 flu, a little bump, but then we got right back on the exponential. So when you take a look at all these costs, the numbers are staggering when you do what I call the Carl Sagan problem, the billions and trillions. But when you look at them as percentages of growth rates, at overall impact on macroeconomic structure, this is not an economics problem. And as Tom said, although it has economic components that are dramatic for certain groups. and therefore it's a problem of trying to define what you value and then helping out the disadvantaged to get through that so they stop becoming blocking coalitions. And that's where this dissembling debate out there is so damaging, because it knocks people off their good sense and makes it very hard to get action, because they think that when the president tells them it would have bankrupted the country, even though, let me be real blunt, it's a lie. I think he probably even knows it's not the truth, but they covered it. Where was the media? Why didn't they run the numbers and show why that's nonsense? It's well known inside the, you know, the integrated assessors. So we have a serious problem, and the problem, in my opinion, is more cultural, and I agree with you. And we need opinion leaders, and we need good graphics, and we need ways to get people back to the values which they fundamentally hold, and get them away from being bamboozled by numbers that are so intimidating they just quit and work on something else. My opinion. In case you didn't figure that out.
Right. Steve is never short on opinions, right?
You sketched out a lot of the problems with the current regimes and sort of potential things, but it seems like they've all got problems. You know, like you listed all these things that have to fall into place. Is there any cause for optimism, or can you point to some similar change in attitude or culture or international legal infrastructure?
No, that's really a good question. I mean, I see cause for optimism, and I am still optimistic that we're going to beat this thing. When I reframe the problem, and part of the reason that I did that reframing at the end is I think that generally you're going to get political results when you pose the problem in ways that seem responsive to solution, as opposed to the kind of thing I did with impossible stuff. So a low-level price signal, I think it's quite possible, if we framed it that way, that we could get Congress to go along relatively quickly, and I think most of the rest of the world is already indicating, that is to say the developed world, is indicating that such a signal is useful, even in China and India. Although I don't see any possibility of a price signal, I do see certain policies and measures which are consistent with that price signal on energy efficiency, air conditioning standards, and things being installed. So I actually think we can get to that level. When I kick it up to the issues of trying to change the development path that is being installed in country, I mean, all I can do is say that I spend most of my time doing this, and when I meet with people who do have decision power in countries and say, gee, wouldn't it, from your standpoint, wouldn't it be a lot better to have an increased percentage of your new power coming from natural gas or something than from coal? They say, yeah, that's really consistent with what we want, but we've got these problems to do that, infrastructure problems, the fact that for bizarre reasons that would take us a long time to talk about, the price of natural gas is tracking the price of oil. Okay, so the price of oil goes up and the price of natural gas goes up with it. There's no economic reason in the world for that to happen. Certainly not in the new markets of Asia. So the delinking of gas and oil prices would have an enormous impact on what gets built. That's a soluble problem. Climate change is a general issue? I'm not sure. But if you break it down into components that are going to have impacts on our climate trajectories, I think we come up with a lot of problems that are soluble. And I would like to see us doing much more of that. And then technology policy and how you bring on new technologies, well, I think that's really essential to get places like Google and others who are innovators involved in thinking through that problem, because, you know, technological change is not something that we have no experience with. And I just don't think that we, you know, if we turn it over to the Defense Department, or even worse, the Department of Energy, they've got a clue on how to do that. So I think a lot of it is reframing the problem and getting the problem into the hands of people who have been successful in solving similar problems, rather than trying to aggregate it the way, you know, we economists did and said, single price signal across the world, that's it. It's not going to happen. It's not happening now. But I'm not unoptimistic about it when you start to translate these things into what do seem to me to be much more graspable and solvable problems.
I have maybe one last question.
Steve can answer yours.
See what it is.
The Chicago Climate Exchange has a pretty low price attached to carbon, and they seem to think that they can use an economic model to solve these problems outside of government, federal policy. But a lot of people have concerns that those credits don't actually mean anything because they're not really certified. Can you just speak to that? And okay, thanks.
I'll say something afterward.
You want to go first?
No, go ahead.
There are a bunch of markets around, some of them operating here in the United States. One of them, probably the biggest in the United States, is the Chicago Climate Exchange. And they allow the trading between members on that exchange in carbon permits. But of course, this has to be completely voluntary with respect to American actors, that a company will take on a target and then perhaps go out and satisfy that target by buying a permit from someone else who has reduced emissions. The price on the Chicago Exchange, I think I can... Okay, so this is maybe a month behind the data. There's a graduate student who's updating this every day, but my slide is a little bit slow. So these are the prices. This is kind of the current price, or the price 2 weeks ago on the European trading markets. And these are the size of these bubbles are the volumes that are being traded. The Chicago Climate Exchange is down here. It's a very, very low price. It's on the range of $1.50 to $2 at the present time, because precisely there is no, it's a purely voluntary exchange. So that my sense is that what's going to happen here is that here we see this odd mechanism called the CDM, which I can explain really quickly. It says something like, if you've got an obligation to reduce emissions in Europe, or you have a voluntary target or whatever, by so many tons of carbon equivalent, what you can do is make a deal with somebody in China or India, countries where they have no obligations, but if they reduce their emissions. So, for example, if instead of putting in a coal-fired plant, they built a wind farm, you can calculate the difference in emissions that will occur over time. You can monetize those as assets and then sell them. The problem that's going on with CDM, and here, as you can see, the issue, this price, the European trading system price, is much higher than the CDM price. But because of regulations that the Europeans have adopted, this can substitute ton for ton for that. So if you think about arbitrage, how can that exist? Why would anybody pay this amount when they could pay this amount? The answer is the pipeline that approves these things, which is a UN agency, has been slow in expanding the supply. So what you're seeing is extremely thin trading on the European market, because people are waiting for this to see how much of a supply there is down there. And what's actually going on in Montreal, as I spent time with Robin trying to explain, and I think she heard it from the European delegates directly, is there is tremendous pressure on the regulator to expand the supply of these credits, so that the ultimate price for compliance in Europe will not be here, but somewhere down here. And the problem that we're having is that the way they're expanding the supply of credits is not in doing things like substituting wind for coal or anything like that. It's in a couple of industrial gases. One, HCFC 22, which is the base for Freon. It has a byproduct called HFC 23, which is a terrible greenhouse gas, 11,000 times worse per unit than carbon dioxide. So if you reduce a unit of it, you can get a huge number of carbon credits. Okay, and for reasons that I'm not going to go into now, I think it's bunk. I think these huge number of credits that are entering the system are not real gains, and we're about to see another huge infusion of fertilizer companies which release N2O into the atmosphere, going to be selling that as well. So I think this supply is going to get pumped up. The price for compliance is going to come way down because of this, and we're actually going to see a Kyoto compliance signal somewhere down here, which is a very low signal, but has very little environmental credibility as far as I'm concerned, because I think this is watered stock, to put it simply. That's the quick analysis of a long problem.
Yeah, let me briefly add a slightly different dimension. People tend to respond to price signals that they believe are long-lived as opposed to fluctuations. Nobody's quite sure about what the regime is going to be. It's the same reason after we had the big pulse in gas prices and then it went back down and then they started buying these 7,000-pound cars again with the tax deductions, because there was a perception it wasn't indelible. So when the single most important reason, in my view, why we need a Kyoto Protocol, it's not going to do virtually anything for the climate in the short run. And if the only thing we did over the century was Kyoto, then you end up a couple of tenths of a degree cooler in 2100. So depending on where the climate probability density function comes out, you know, you're 3 degrees versus 3.2. That's clearly not sufficient. In fact, people have derided the protocol as not working. What the protocol is it's an experiment in learning by doing in cooperation. And I'm not disagreeing at all with the pillars approach. I think we need to have multiple strategies. But the single most important thing, in my opinion, that would trigger people to invest in alternatives and not be so afraid is if they actually believed that this was not only going to happen, but it was going to go up. As we heard from Tom, people don't perceive that now. They don't know what's going on. So what you do is you lack that incentive. You want to do well. You don't mind helping the world and doing good, but you don't want to be a fool. You don't want to be the one to buy up there when you know others are going to buy down there. So then you end up setting up perverse incentives to going in the right direction because of this patchwork and the lack of enforcement. One last thing on that. 100 and some odd cities in the U.S. were members of this ICLAI network and have climate policies. So one of my students a couple of years ago in our senior honors program decided that she couldn't understand that because she learned in economics class about the free rider problem. Well, so even a big city like Los Angeles, if it got it cleared up its act and everybody drove a hybrid and they no longer bought electricity from the Nevada coal plants, and they cut their emissions in half, I mean, we're talking 0.1% of the world amount. So there's still, in a sense, a free rider on the overall commons degradation of everybody else. Why should they spend positive money cleaning up, except if it has political bump? Well, so we checked around with these 150 cities, got about 50 responded, and found out politics was only the initial driver. There was a charismatic who came along and pushed the city council to listen. That's not what determined why the cities eventually signed on to climate policies. It's because they perceived that by putting light-emitting diodes in their traffic lights, thereby having 100,000-hour bulbs, saving a lot of labor on changing lights, plus they could calculate out quickly the return on investment was very, very good. But if they have street lights that don't light the bottoms of airplanes, but instead only the streets, if they have building codes that get single-pane windows out and double-pane windows in, I know it predates you, but things of that kind, that everyone, or if you have a diamond lane and you reduce crowding and air pollution, which reduces health costs and makes the city more desirable for high-tech business to move in, that they actually are getting positive cost-benefit ratios that economists call no regrets. That means that you don't need climate, you should have done it anyway. And there's a big debate among economists and engineers about how much no regrets there is. But be that as it may, it was the perception in those cities that they were actually getting economic or quality of life advantages that drove it. It was not that they thought they were going to solve the climate problem. And by the way, we feel like better citizens because we're making a statement. We can't rule the world, but if we're profligate, then we have no credibility to tell them not to. You hear that over in Seattle says that all the time. So I do think, back to your question, Carl, about ideas and values. I think that we have a lot of opportunity from the bottom up. If we could get some top down to make it easier from the bottom up, we run a mixed strategy between these. We're learning by doing, we're fumbling around. The bottom line is we've got to cut emissions to about 50% below business as usual projections by mid-century and down near zero by the end, or we're doing more than doubling CO2. And that's one heck of a tall order, and I'm not particularly worried about whether Kyoto, with or without some entity, is cutting 3% versus 4%, because I don't see the difference in 100 years between 3%, 4%, and zero. What we have to have is major cuts, and what we need to do is develop the cooperative model necessary so that people want to participate. So economics is part of it, incentives are part of it, but good old values is the whole thing.
Here's the disagreement between us about this whole thing. Steve and I are in no way disagreed that a low-level price signal will produce real gains for us. Okay, it should be that there are big gains to be had, depending how inefficient. I'm going to talk like an economist now, after I've criticized my whole profession. There are big gains to be had for very low cost. Okay, maybe even no cost. The system is rife with inefficiencies. The more inefficient the system, the cheaper the cost. Part of the reason why Europe went much faster than the U.S. is the U.S. was dealing with inefficiencies in its energy system since 1978 under the PURPA, which was an act that we passed in 78 in response to the first oil crisis. And Europe was filled. If you look at the European energy directives, they didn't happen until 1998. Implementation has still not taken place to a full degree. So that the further you are, well, I'm not going to talk like an economist and say further you are from the frontier. The more inefficiencies you've got in the system, the lower the cost of cleaning it up. And we agree there are lots of inefficiencies. I think we also agree that getting the inefficiencies out of the system is not going to deal with the climate problem by itself. The magnitude is not big enough. Where we disagree, and where I guess I disagree with most people who are more optimistic, is whether the steps we have taken to Kyoto are a good foundation for using that same structure to get the price levels up to the levels that are necessary to actually deal with what I call diffusion and innovation. And my answer is no. They're not level, and that Kyoto's architecture is not an adequate foundation to build upon, and we're going to waste a lot of time fighting to try and get Kyoto to a place where it can't go, and I'm saying step back from it. I want a low-level price signal, but let's focus on other sorts of mechanisms and incentives that are tailored to getting beyond the low-cost efficiency gains that I certainly agree with Steve are out there in substantial amounts, but not in big enough amounts to deal with the climate problem over time.
That's it. Yeah. Don't disagree.